Welcome to this session. We're going to talk today about the steps of problem solving and how you can go through and use these just in everyday life to solve your problems. We know this is a computer class, but there's a lot of information here that you can use in various different areas. So let's get right to it. We're going to call this the 5 Ds of problem solving. All of the ideas that we're going to use, all the terms that we're going to use to identify each specific step is going to be start with the letter D. So when we're talking about problem solving, we thought this is a program writing lesson. Well, program writing and problem solving are actually the same. So when we go through the program writing process, we ask ourselves some questions. Why is it important? Well, this process helps the user to understand how the program works. It helps the user to understand the software limitations, and it is the same procedure as solving a problem. So it's a life skill that we're going to talk about today. The program writing process has 5 steps. The first one is to define the problem, design a solution, do it, develop it, code it, write it, debug and test, and then document and maintain. So let's talk about each one of these steps. First, to define the problem. To define the problem, you have to study the problem. You have to know what it is. You have to ask questions about it. You have to determine the specifications. You should know what the out should be. When you're trying to resolve a problem, you should have some idea what you would like for the eventual resolution to be. You determine the processing techniques, what you have to do to get from here to there. You want a goal. The goal is to solve a problem. What steps are you going to have before you solve that problem? And then you need to identify the information that you need, the input, the resources that you need to process that. This is all a part of your preliminary investigation. Basically, what you want to do is to gather as much data as you can at this point. Next thing you're going to do is design the solution. This is a similar technique to creating an outline for a theme or a paper, or producing a blueprint for a house. There are a lot of techniques. You can use a pseudocode. Pseudocode is false code. It's just some scribbles that are written down that say do this, do this, do that. Structure charts, sketches, a flow chart. You can actually create a working model, a prototype. Just something quick like this, just where you go through and you identify the different parts, the main menu, the input, the processing, the output. Fill in some of the gaps here. That will be most helpful to you. The third step is to develop the program, to actually do it. This is where you actually write or code the program. So you have to have some idea of the process and the language that you're going to use. Experience goes and helps a lot in this step. And you're going to be moving from the design, from the theoretical to the actual practical, to the actual application. You're going to put your plan into practice. The next step is to go and debug and test. So you've gone through and created a program. You're going to debug it. You're going to see if there are some problems with it. So you're going to run the program. You're going to try to make it fail. You're going to look for errors. You want to test the program completely. And you have to check every little insignificant detail, and this is where your skill and expertise of the programmer or the person who's the expert, the content expert, is going to be very important in this phase. Sometimes it's called the implementation phase of the project. Now, some of the errors that you may see at this stage would be syntax, a violation of the grammar rules. You didn't spell a word right, and there have been some serious mistakes that have occurred lost a lot of money. People have lost a lot of money because of the grammar rules. There are some runtime errors where the user puts in the wrong or incorrect information. I think all of us have probably had times when the computer has beeped at us. And these are because of runtime errors. And then logic errors. These are the most serious ones. These are the ones where the program runs but it gives incorrect results. They are the most difficult to find and correct. It causes the program to be unreliable, and it is the most dangerous. And along with this information presented to you, there are some other written information that you can read, and you can see some of the examples of each type of these errors. So how do you find the errors? First of all, you use the program. You run it. If you're not necessarily writing a computer program, if you're doing something else like building something, well, you use it. You actually see how it works. You test it. You check it out. The types of tests that we can run. An alpha test is one that is inside the programming group. This is done by the people who know how the program works. So they're going to maybe not look at everything because they're going to make some assumptions. And then the beta group is outside of the programming group. These are the people who will try to use it in ways that the alpha group didn't even think about. And so you will hear about beta testing sometimes, and that is that second level of test. Some of the classic errors, the airport control towers, this is in some other material that goes along with this, the Therac 25, which was a radiation machine that actually killed a couple of people. AT&T had an outage on the East Coast because of a programming error that's in some other material. The Bank of New York lost like $5 million in a day because of a computer error. A communications satellite was blown up because of a programming error. Again, this is material that's in other things. Let me just spend just a little bit of a second talking about the HMS Sheffield. There was a war, the Falkland Islands War, between Argentina and Great Britain. Great Britain sent the HMS Sheffield over there. The HMS Sheffield was trying to conquer back the Falkland Islands, which are about 200 miles off of the coast of Argentina. Argentina sent their Air Force out, and the guy had a missile. It was a French-made missile. And so the guy had the Sheffield in his sights. He launched the missile. Immediately, the Sheffield picked up that a missile had been fired at it. But it did not alert the crew. It did not take an evasive action because the missile was made by the French. And since the British and French sort of feel like they aren't going to fire missiles at each other, then it didn't alert them. It picked up the signature, but it did not tell them that there was a missile headed their way. And so as a result, the HMS Sheffield was sunk, and they lost about 30 soldiers because of that. It was a programming error that caused the loss of life there. So the cost of errors. If you were to go and estimate the cost of finding and correcting an error during the first stage of the process, it would not be very great. And then once you find it and correct that error during the debug stage, it becomes greater. And then after the program is actually in use, the cost of finding an error after it's placed in use, we find out that the cost of errors increases exponentially as we go through the processing stage. So you do want to find those errors early in the process. I'm going to put this on YouTube. I only have 10 minutes. Those 10 minutes are up, so I'm going to do a second one of these. We'll check back with you in just a minute.